So I stand here today, and the first question I've been asking myself in preparing for this is, why am I talking about maintenance? Anybody who knows me knows I really love to talk about S&C, but a lot of what I talk about is the new generation of NR60 or the tubular stretcher bar. And can we just have a show of hands? How many people work in maintenance, track maintenance, S&C maintenance in the audience? We've got quite a number. That's good. That's good. Excellent. So I know when I worked in maintenance, and I was an assistant TME for a time in the East Midlands in Derby, and I used to think there's all these people who don't do the maintenance, and they come along and they're starting to tell me how to do it, and it's very different when you're doing the job. So this is really what I was thinking about. Why am I talking about maintenance? Well, I did used to work in maintenance. I've been involved in S&C since then. I get asked all the awkward questions. So the maintenance engineers say, we're not quite sure what's happening here. We can't explain it. Can you explain it? And sometimes I can. Sometimes I can't straight away, but I go away and I talk to the vast array of people I know, and a number of them in the audience, and they say, yeah, idea about this. And I try and come up with an answer. And sometimes I have things going around in my head for years and years, and then one day I suddenly go, that's the reason. And then I can go back and say, this is what we need to do, and this is how we work. So anyway, that's talking about maintenance. So a bit of an overview of what I'm going to talk about today. Why bother? Why bother with maintenance? And then I want to take a step back. So this is what I've been doing over the last few years. Instead of being focused on the day-to-day delivery of the maintenance and the day-to-day problems, what are the actual principles of S&C? What are we actually trying to achieve? What within our maintenance, within our inspection and our maintenance work, what are we actually trying to do? Thinking about what good looks like, and then thinking about the problems. And it's important to understand the cause and the effect. And then it's all about planning, but it's planning the right solution. You know, so many times when people have had problems and they've been doing something for year on year, but the problem keeps coming back. And it's all about understanding the right solution and then having the tools and the time and the resources to implement it. And again, I think anyone who's involved in maintenance, they always feel they're sort of put on by everyone else, they're getting pressure from everyone else. So I'm going to talk about challenges at the end. How can we all help? Because I believe that we can all help to support maintenance engineers and to support the maintenance process. If someone stepped into the room now, they'd think they've got the wrong conference. They'd think it's not the PWI. This is about washing machines and cars. And David, in his presentation, mentioned about the whole life cost. And it's something I've talked about for quite a number of years. And I hear a lot more people now talking about whole life cost. But when I was thinking about this maintenance question, I'm thinking, well, we do it all the time. We do it in our everyday lives. It's when do we buy something new? How much do we spend on maintaining it? And so washing machines, like we had to buy a new washing machine not long ago because the old one had broken down. And I remember saying to my wife, I'm sure 15 years ago we paid more for a washing machine than we're paying now. So the actual cost of the washing machine has come down. And if I call someone out, when it went wrong, should we call someone out? It's like, well, you end up paying half the price of a new washing machine in paying the repairman. So it's a whole life cost argument. You know, it's the washing machine, the domestic appliances. We've really developed it's a throwaway society. I don't say I agree with it, but that is the reality. It's not economically viable to spend money on repairing washing machines, spending a lot of money. So that's a whole life cost decision. A car's a different matter though. We spend more money on a car, but if I didn't service my car and I decide to drive it for 5 years and never do anything to it, and then say, well, it's okay, I'll just go and get a new one, then again, that wouldn't be a sensible approach, would it? So the whole life cost argument is different depending on what you're buying. And I've tried to list on the slide there, it's thinking about the purchase cost, the maintenance cost, but it's the implications of failure. It's, you know, the car breaking down, the washing machine breaking down. It's an inconvenience, but equally there can be safety implications as well. With cars, it's the tyres, the brakes. I suppose it could be with the washing machine, but there's safety implications. The other thing, of course, is the expected life. With a washing machine, if it lasts 5 years, it lasts 8 years or whatever, you might be quite happy. But thinking of, back to the S&C now, thinking about the S&C, we expect the S&C to last an awful long time. So I think what I'm saying is, if thinking of the S&C, it's the purchase cost, it's the maintenance approach, it's the cost of it, but it is then thinking about the whole life and the life that we're looking to achieve. So yes, so that's enough of washing machines and cars. We'll go back to the S&C now. I was talking to a guy called Steve Richmond a few weeks ago. Steve Richmond was a TME until quite recently. He's been a TME for a long time. And he's writing some training materials for us. I'll talk about this a bit later. We're developing new training materials for a lot of activities, but for S&C maintenance, S&C inspection, S&C maintenance. And one of the I was looking at some work that he'd done, looking at some of the historical training material, and I said, a lot of what we do with S&C, we just look at the bits. We look at the switch rail, we look at the slide plates, and I said, I take a step back. And again, this is the difference between, I think, a maintenance engineer and you know, an S&C systems engineer, which is what I think of myself, and saying, what are we asking the S&C to do? And when I go and look at a problem, this is something what I do. I just take a step back and just take a slightly different look at it. So I tried to list the key principles of S&C, and they might be quite obvious, or they may not be. So it provides guidance of the wheel, and it provides wheel transfer in the switch, and wheel transfer in the crossing. And obviously we've got things like geometry, the gauge, and the switch and crossing profiles. They all influence the way that we guide the wheel. It provides support to the vehicles. David talked about the Planeline Plus. It's like Planeline. It's supporting the vehicle, but there's obviously more equipment in there. There's more complexity. Hopefully it provides a reliable switching operation. That's what it's all about. That's what we end up getting delays if it doesn't work, but that's, again, a key requirement. But it has to provide security of all the above. So all of those things, it can't just do it once. It has to do it over a very long time. And over that time, the asset condition will change, but it has to maintain all of those. So, thinking about problem identification, and this is, again, it's my experience, it's looking at the questions that I get asked. The first thing is knowing your asset. So, again, when we talk about the S&C training, and I say, well, there's different families of S&C. We've got the old inclined S&C, we've got bullhead S&C, we've got full depth, vertical, shallow depth, vertical, RT, and people go, no, you make it far too complicated. You know, we just need something simple. And I say, but if you don't know which life of S&C you've got, then how do you know which set of drawings to look at, which set of rules to apply? So it's really important to actually know your asset and to understand what life of S&C, what family of S&C it's from, the size of the switch, but other things like point operating equipment. Again, a lot of track engineers don't necessarily think about the points operating equipment. It may affect the track, it may not, but in the S&C systems world, you have to think about the points operating equipment. The other thing is the geometry. I'm going to talk a bit about geometry in a bit, but really the point here is, if you don't know what you've got, if you don't know what you're dealing with within your asset, how can you start to understand, A, what it should look like, and B, what you're supposed to be doing? So over the last few years, we've been developing the Ellip system to hold a lot of this asset information. So there's a lot more of this information now that's available to us if it's been populated properly. So my first plea, if you like, to the maintenance world out there is, with Network Rail particularly using Ellips, but to the wider world, it's actually get your asset information in a database and actually use it and actually understand it and actually use that to plan and to give you information before you start. So these are my principles then that I've talked about already. Geometry. If I knew as much about S&C geometry when I was a maintenance engineer as I know now, I could have done a better job, because S&C geometry is quite a specialised subject. Now, you don't have to be an expert in S&C geometry, but if you understand what what it should look like, the principles of where rails need to be curved, where rails need to be straight. Because, you know, this is one of the things you sometimes pick up. You go and look at a piece of S&C, and somebody say, this isn't performing very well. And you say, well, is that the right crossing or is that the right switch that's been installed there? But if people had a better understanding of the geometry of what, you know, whether it's supposed to be a straight crossing or a curved crossing, then it would be a lot easier for people to spot that themselves. I talk a lot in my world about standard geometry and non-standard geometry. We have REPW drawings for virtually all of our S&C, but it's all based on standard geometry. Once you go away from standard geometry, then you need to look at a site-specific layout drawing. Again, as the maintenance engineer, do you have access to this information? Have you been provided with this information, and do you actually understand enough about it? The other thing within S&C is the relationship between the through route and the turnout route. On concrete bearer S&C, the position of the bearers affects the distance between the straight rail and the curved rail. And sometimes I've seen examples where things haven't been installed properly, so the spacing's not been achieved. And then within maintenance, people are trying to correct that geometry. So this is about the right solution, understanding the problem. If you've got the wrong relationship between the straight rail and the curved rail, then sending in a tamper isn't going to correct that geometry. You can either make the curved road right or the straight road, but you cannot actually get the two to relate to each other, to be in the correct geometry. So we see quite a few examples of that, and again, it's people actually having the knowledge, having the understanding, getting to the root cause of the problem. It isn't it's a simple geometry problem, it's quite a complicated geometry problem, it's quite a complicated process to put it right, to move the bearers. But the point is, if you don't do that, then you're never actually going to get it right. So whatever else you're doing is going to be a compromise. So the other one is, one of the other principles talked about wheel transfer. And one of the things I like to do if people go out on track with me is put a TGP8 gauge on the crossing. And something I always do, because again this is what the crossing's doing, it's transferring a wheel from a wing rail to the V, to the nose, or the other way around. So if you drop the TGP8 gauge on the picture on the far right there, then you can actually see what the wheel's doing. So if we don't get the right wheel transfer, then we can end up with lots of other problems. We can end up with higher impact forces, we can end up with accelerated wear. So in the 054 standard, we introduced some changes a few years ago where we actually do a check, and the picture in the middle there is one of my colleagues doing a check on a crossing. So he's using a straight edge and just checking for the level of wear. And there are now requirements in our Network Rail 054 standard to say, well, if the wear's above a certain value, to weld it up. Now that's created, certainly in the short term, quite a huge work bank. It's created quite a lot of hassle for people. But again, it's part of delivering a solution, actually restoring the crossing to where it should be, and it will actually stop some of the degradation of other components around it. The other thing I talk about with crossings is, when I think about wheel transfer, is I say it's not a crossing, it's a crossing panel. So the picture on the left, something we're all familiar with, but don't just focus on the actual crossing, think about the panel, think about the check rails, think about how the two interact. And again, it's something that you can do with a P8 gauge. You can actually see whether the check rail's active and where it's positioning the wheel set. Switch alignment. David talked about managing risk, and this is obviously one of the key areas where we manage risk. We're far more likely to derail a train on a switch than on a crossing. And 3 pictures up there, 3 pictures tell a lot of stories actually. But what's interesting there, well, there's several things that are of interest. So the one on the far right there is a straight switch. So the wheel transfer is happening there, is relatively straightforward. But the middle picture, it's obviously the curved switch, but there's also a main line radius through there as well. So it's the same action of wheel transfer, but you can understand there where the two situations are very, very different. So they're very different from a geometry point of view, so the steering forces are a lot higher, but from a maintenance point of view, well, there's more risk associated with the curve switch, but also the level of wear is going to be greater with the curve switch. When I'm looking at wheel transfer, I tend to spray the rails up, spray the crossing, and the one on the left there, interestingly, it's actually an NR60 switch that David was talking about, so that we were looking at the wheel contact on a trailing switch. So spray it up with paint, and then you can see where the wheel's contacting, and you can see where the wear is occurring. I put the pictures up there to talk about wheel transfer, and then I noticed that the picture on the far right has actually got a misalignment in the heel block area as well, which is another common problem. But there's all of these things that are there that are in play, and I think this is the problem. You start looking within your S&C, and you actually start realising there's a lot more in there. Neil Denton's going to talk about gauge, so I'm not going to say too much about gauge, but again, take a step back. We all know what gauge is, we all measure gauge, but within S&C it's not always that straightforward. So primarily it's the position of the rails, or it's the position of the switch and the crossing in relation to each other. So I'm not talking about structure gauge, I'm talking about track gauge here. So, but as we know, we put a gauge on in S&C, and we sometimes get a result where we're not expecting. Now that might be because there's something wrong, or it could be because the reading we're taking isn't giving us the answer that we expect. So just to think about the factors that can affect that. So obviously wear, well, and me and Neil had a long conversation about this at one time. When we measure gauge, it's the position of the rails, but it also, obviously, the wear is affecting gauge measurement, which, again, is quite obvious. But when you're trying to plan how to rectify it, you need to take that into account. You need to think about it. On certain designs of switch and on certain crossing areas as well, you cannot measure gauge because the machining on the switch or the crossing has actually taken away the reference face where you would put the gauge. So again, it's thinking about this, it's having this knowledge, measuring it in the right place. And also if the switch is open or closed, but if it's closed but not quite closed, so if there's what we call a residual opening between the switch and the stop rail, it will give you a different gauge measurement. I've not stolen Neil's thunder. I think I'll let Neil talk about gauge, but I just wanted to have my say on the principles of gauging before Neil talked about gauge. Providing support. So I said it's plain line plus, but within the S&C we've got more components. We've got different components, and starting on the right again there. Obviously we can work up or down. Let's go from the top down. We've got the crossing. We've got a pad under the crossing. We've got a base plate. This is an NR60 S&C. There's a pad under the base plate. We've got the bearer, and obviously the bearer is sat on ballast, and then you've got the formation. All of this is contributing to the support. As you know, within S&C we get problems with support, and it's normally at the wheel transfer areas. It's normally in the crossing nose area, and it's at the switch toe. And Peter Musgrave's in the audience. I was having a chat with Peter just before we started this morning, talking about stiffness, understanding the support stiffness, and there's lots of work going on at the moment to try and understand the stiffness. So we can design the system to give the right stiffness, but the point I'm making is if we haven't got the right components in place, and components in the right condition, then we're not going to get the support stiffness that we need. The overall stiffness, it's a simple load displacement, so you run a train over it and it moves. Again, thinking a bit later about cause and effect, if we don't have the right support stiffness, it will lead to other problems. The middle picture there just shows what happens when, well, there's two problems with that picture. One's quite clear, the other one is less clear. I'm not deliberately mentioning any locations today because I don't want to offend anybody, but the pad's almost out, obviously, but on closer examination as well, the base plate is too wide for the crossing. So where the clip's in place, the clip's barely sat on the foot of the rail as well. So, so again, it's all affecting the support. So, talked about geometry and support. I mentioned in my early slide about security, and so it's having the correct and effective components in place. If you don't, then things are going to move around, and having the right ballast conditions and levels. But on curves, then you may need to do other things. So it's building in lateral support. This picture's not from the UK, it's actually a picture from Switzerland, and it's an interesting one. I found the picture because I was talking about this in a meeting the other week. Some countries use a sole plate or something similar around the crossing nose. So we look at keeping check rail gauge. So this is the relationship between the check rail and the crossing nose. So in Switzerland, they've got a steel plate across there to actually keep the space between the crossing and the check rail in one place. It's all about the security of alignment and everything else. So really what I'm saying is, so as a maintenance engineer, you go and look at the S&C, it's looking at it, it's finding what the problem is, but then it's thinking about how we can actually keep it there, how can you hold it. Aggressive wear, that's, I didn't quite know what to call this slide, but aggressive wear was, you have certain sites where you get a lot more wear than others. There can be a number of reasons for that. And some of it is down to the actual materials themselves. So is it the correct crossing or switch that's been installed? We've talked about premium rail steels and so on, which is another story in itself, but they have a greater resistance to wear. Different designs of crossing are designed for different duty cycles and will stand up to a lot more wear. So it's about the materials, but it's also about the correct maintenance regime. If you get more wear, again, it's quite obvious, if you get more wear, you need to do more maintenance, you'll need to go in there more often. So if you're getting aggressive wear, then it's understanding the cause, and then it's deciding on whether it's a matter of changing the components or whether it's looking at an alternative maintenance regime. So 2 examples I've given there. The one on the right, that's a cast crossing. Now that's a cast crossing pre-explosive depth hardening, so it's an EDH, and it was one of the crossings I used to try and persuade people, one of the pictures I used to try and persuade people that an explosive depth hardening was the right way to go, because that's an obtuse crossing. Is it very clear there? So the black thing on top is a straight edge, and you've got the casting there. The light area, so this area here, that should be full of metal, and that's a depression that's caused at the point where the wheel hits the cast crossing as it transfers. When you start looking at the design of a crossing, then people work it out and say, a millimetre can make a difference. What height should the topping be? If you get something like that, the crossing is never going to behave like it's designed. The impact force is going to be a lot higher, and again, there are lots of other issues at that side. So that's an issue where a different material, an explosive depth hardened crossing, will make that situation a lot better. The one on the left is, like I say, it's an NR60 switch where lots of issues going on with that at the moment, looking at geometry and everything else. But again, we've been experimenting with the harder steels. Maybe a different grinding regime will be required in that as well. So again, back to the principles. I talked about reliable switching, and as you probably know, the team that I work in Milton Keynes, one of the good things I like about the team, I like a lot of things about the team, but one of the good things is we have track engineers and signal engineers working in a team. So we look at S&C as a system. There's less of a problem with crossings at the moment, but certainly with switch panels, it's a great combination, and it's something that we're trying to promote throughout the business and throughout the industry. If you get the track engineers and the signal engineers working together, look at the switch as a system, then we can get reliable switch operation. So again, you look at it initially as a track engineer, you'll look at the slides, you'll look at the rollers, You may stand back and look at the switch flexure. Is the switch actually behaving as it should? Is it aligned as it should? But then when you start to look at the setup, you've got setup of the points operating equipment and the setup of the actual switch. And it's actually understanding what the signal engineer is trying to do, what the signal engineer's requirements are, understanding again from the other side, from the signal engineers understanding what the track engineer is trying to do, and how we can actually get the system set up to operate. I've talked a few times about cause or effect, and again this is one of the things I found a lot, that the effect is normally the most obvious, and people hone in on the effect. And again, I think Neil will be touching on some of this. So people say, you know, we've got this part that's broken, so we'll replace it, and we replaced it, and it's broken again, and it's like, well, but what's the cause? What's the root cause? And that's when it gets difficult, because it's not that obvious. So and again, it's time, it's access, it's everything else. But if you don't obviously get to that cause, then you're going to be chasing your tail for a number of years. So the first bit of advice I'd say is I say look further away. Take a step back. I won't take a step too far back, you won't be able to hear me. But take a step back, because the problem, the cause, may not be at the same point as the effect. So there may be a problem at the rear of the switch that's affecting how the front closes up. There may be some wear on the switch that's caused by a geometry fault that's a length away as you approach the switch. So that's the best bit of advice. Determine the root cause. Say that's a really difficult one. But again, we've talked about geometry faults. You look at the geometry, but the wrong components can be installed. So you might have the wrong pad, you might have the wrong type of base plate. We've heard of examples where someone without the knowledge has put one base plate under one half set of switches and a different plate under the other half set, and we've ended up with one switch 5 mil higher than the other. It manifests itself as a geometry fault, but it's not about geometry, it's about componentry. It's this cause and effect. So the really important thing is about finding the root cause. So, questions to ask. So this is really my thoughts on, if you go to look at some S&C, then how do I get to the root cause? What should I ask? So really going back to what I've said, what should the S&C look like? What is the design of S&C? So what do the standard components look like? What are the site-specific requirements? What are the geometry? If you don't understand what it should look like, how can you start to determine what's wrong? So think about then the maintenance history. If you've got repeat problems, then you need to understand that. And again, I always say to track engineers now, look at the performance. A lot of the performance issues are reported to the signal engineer. They may come to the track engineer, but if it's reported as an S&T fault, then the track world may not be made aware. And it may be a track fault, it may be a system fault that requires input from both. So the maintenance history and the performance history. Is the S&C correctly specified, supplied and installed? And again, it's something that we get quite often talked about, the two base plates there. If you've got something that's wrong, never assume. I think somebody told me that a long time ago. Never assume. When you're supplied with something, or you go to a new area, never assume that everything is as it should be, because question everything, because it's likely there's something in there that's not quite right. I felt I had to put the next one in. Is there an inherent design issue? We have problems with S&C. We have issues that we're trying to resolve. There is really an inherent design issue. The NR60 switch blade training wear is a classic example. So really what I'm saying is be aware of it. What we don't want is people trying to solve a site-specific problem where it's actually an inherent issue. So it's learning about the inherent design issues and understanding them and recognising them. And is there another factor causing the problem? There could be an external factor. It could be something like a new set of rolling stock that's running on the area. Think beyond that. Is it something to do with the embankment? Again, it could be a wider problem that you would get with plain line, but it isn't necessarily a problem with the S&C. Think a little more widely. you've got complex S&C, so this is something, again, it crops up within training, within lots of things. If you've got complex S&C, then it is a specialism and treated as such, and you could take that a number of ways. And I think really what I'm saying is, if you've got complex stuff, ask somebody for help. Ask somebody who knows. There are very few people who understand all the aspects of complex S&C. And you know, what I always tell people is, if you can understand the standard, relatively simple stuff, the common stuff that you've got, that's great. If you've got complex stuff and you understand it, that's fantastic. But don't get bogged down, don't get confused by all the complex stuff. So Roy Hickman's smiling because of one of those pictures, but we'll talk about that later. So I talked about the challenges. So these are the challenges for all of us, and I've split the challenges into 3 areas. So, like I said, these are challenges for all of us, and it's how we can all help the maintenance engineer and the maintenance process. So, new technology, developing a product and a system that needs less maintenance. So I think my 2 examples there of the washing machine and the car. Cars and washing machines today need less maintenance than they used to. The products have been engineered in such a way. And that is something we have to strive towards. But not forgetting, of course, that the products we've got now, that were installed in the past, still need the maintenance, still need the TLC. But it's not just about technology within the S&C itself, it's developing more efficient and effective maintenance solutions, and I'm sure today we're going to be hearing more about those. These might be heavy maintenance or life extension solutions. I put the next one in about implement them. I was meeting with the track rams yesterday, and I was talking about NR56V S&C, and I think I talked about that when I was here last year. And we've got a new design, and we've done some trials and some pilots, but actually getting the business to actually implement them is a difficult process, and this is because there are so many different people involved, and clients and contracts and specifications and things like that, and that was one example. So we have to be cautious to the point that we know that the technology is right, but at the same time we have to actually implement them, because having an idea on a drawing board as a proposal doesn't solve the problem. It's only when we implement them, and it requires people across the business, across the industry to do that. The other thing that I'm very keen on is when you introduce something new, it won't necessarily be, very rarely is it going to be 100% right as soon as you implement it. So refining the processes or refining the S&C is a key thing. So you implement something new, you review it, you refine it, and then you implement those changes. And again, really, it's how can we all help? In all cases, if we manufacture and install the S&C to the required standards, and that's not a dig at anybody, it is just making people aware, but some of the maintenance problems we have are caused by something either not being made properly or not being installed properly, and then it's a maintenance nightmare for the next 40 years. So that's the first set of challenges. David touched on this again, on competency, knowledge. So there's 2 different things there, knowledge and competency. So today's about knowledge, and it's really good, and I know there have been other PWI events talking about S&C knowledge, but it's really important that we share knowledge of S&C. And I tried to think, well, what knowledge? In 3 areas. It's the principles of S&C, which I've talked a bit about today, that broadly don't change. But in the maintenance world, you need to understand the old designs, but you also need to understand the latest technology, and it's very much this blend of the 2. As I said, within Network Rail, we've got a programme going on at the moment called Role-Based Competency, and that was the material I was talking about, the conversation with Steve Richmond. But there's a lot of initiatives going on to develop competency within S&C, and it's really important that that's done. But the key thing there as well is to formalise it, is to actually put it into a system and maintain it, because doing things in an ad hoc basis, on a local basis, it's all very helpful, but it doesn't preserve it for the future. So it's really just developing this competency framework. And again, it's not just about maintenance, it's about design, it's about the construction, the installation, and the maintenance. So those two are really saying the poor maintenance engineers, how can we support them? The third one is really about the maintenance engineers and the people who manage them. It's about maintenance philosophy, and it's about developing strategies for effective and timely maintenance. We had a Network Rail conference in Derby a few weeks ago, and there was one of the speakers there I was really impressed with, a guy called Dan from Bristol, and he came up, and I'll just read what's on here and then I'll tell you a bit about Dan. But you've got to have this philosophy for maintenance. You've got to provide the resources to do it, and I know that's a big challenge in today's world. No one's got the resources to do things. You've got to treat S&C as a system, so if you can get the track engineers and the signal engineers working together. But it's all about delivering the right solutions. So don't do the wrong thing. Do what's right. And I've talked today about the different solutions and try to take a step back and determine what the right solutions might be. But there will be a short-term, a medium-term and a long-term solution. You may not be able to do the full job immediately. You may have to go and do something, but you need to accept that is a short-term fix, and there's another longer-term action that's needed further on. But if you don't raise that, if you don't ask for the money, if you don't plan to get into the possession in 12 months' time, then it will never happen, and you'll just be going back every 3 weeks to do the same work. I'm going to talk about the guy from Bristol, from Dan, that they'd set up this team. They'd had a lot of coaching from Neil and others, so it was a joint team with track and signalling people. They'd done a lot of work on the S&C. They'd understood and they'd tackled some of the root causes. They'd reduced their train delays associated with S&C by 80%, 80%. And a lot of people, you know, in the room were saying, but how did you manage to get the guys? How did you manage to do all this? And they'd managed to sort something out in the DU to do it. But the benefits, and this is really what I'm saying, if you reinvest those benefits and then you do more of the same. So if you can reduce your train delays, then you get such a benefit from that within a route or within an infrastructure business, and then reinvest that and then keep going round. And it does, you know, it really made me feel happy that somebody had actually proved you can do it, because if one person can do it, then everybody can do it. And the one at the bottom is a bit of a poignant one. Just remember, S&C, it doesn't have an infinite life, or an infinite and a maintenance-free life. I know sometimes people think that, you know, I've had this crossing on the west coast for the last 15 years and it's cracked, it must be a bad crossing, and it's like, crossings aren't designed to last forever, folks, you know, it's like switches, it's like everything. And it will need some maintenance, it will need some TLC. So I got a quote, I wanted to read a quote, and this was, because I went through the presentation, and I don't know if I've said the right thing, the wrong thing, I don't know if I've offended people, but I did what I did, and then I picked up the, so this is from the PWI, British Railway Track Volume 5 on S&C maintenance, and it's in the introduction. This was written by David Cope and John Ellis, and it said that the effective use of materials and maintenance techniques can be achieved only if the maintainer has an understanding of the way in which the layout he is attempting to maintain is constructed, its geometry, and the characteristics of the individual components in the layout. And to this must be added an understanding of the fundamental requirements of track maintenance per se. And that is knowing the correct point in the life of a layout in which maintenance should be undertaken, rather than waiting until the condition of the track makes any rescue improbable. And he'll then go on to say that all too many layouts are run beyond the point at which maintenance degenerates into complete renewal, simply because a critical assessment of the track based on knowledge and understanding was either not undertaken, or if it was, the assessor did not see or did not understand what he saw, which I thought was actually a very good summary. So anyway, thank you very much.